Nick, if you're ready. Nick, do I have you?
Right here.
Awesome. Okay, guys, I think we're going to get underway. We are very conscious of everybody's time today. As people come in, I'll just keep letting them in. A few things to get started. One, thank you so much for joining us today. This is awesome. So glad you are able to attend. I would like to start first off by just letting you know all questions, if we could please hold them till the end. There'll be a Q&A period. This way we can at least get through the presentation, and if anybody does have to sign off, they at least get to see the full presentation. I would like to introduce our speaker. Our speaker today is Nick Anastas. Many of you may know him, if not in person. I'm sure his reputation precedes him. Nick has worked in the industry for many, many years, and he's worn numerous hats. So he's very, very knowledgeable, not only about the industry. He's our present. He is the Ontario chapter president. He is the past National GIS Committee chair, and he is on the NAAWS committee. That's the manual committee, and has been on the authoring team for both NAAWS 3.1 as well as the latest edition 4.0. So he sleeps and eats NAAWS, I'm sure. So if you ever have any questions, Nick is your go-to man. So without further ado, I'm going to hand the floor over to Nick. Just for those coming in, if you could please keep your questions till the end, and if everybody could please mute themselves during the presentation. Thank you all again, and Nick, please go ahead.
Thanks, Lori. And everyone, it's really an honor to be here and to do this presentation for you. And I'm actually really would like to thank you all for being here. This hour that you're giving up really represents a contribution you are making to bettering the millwork industry, bettering the millwork that you provide, which betters us all as an industry and as an association. So the time that you are spending is appreciated and really valued. So on behalf of AWMAC Ontario and AWMAC, I really actually want to thank you for being involved. Without further ado, we're going to get into our presentation and start looking at what we're going to cover here. Some of this stuff might be a little redundant, might be a little bit what you already know, but we're going to go over it because we like shop drawings in general, dummy-proof everything and make sure that all information is there. So without any further ado, let's hop in. So drawing to NAAWS 4.0 standards. Learning objectives today is by the end of the presentation, you're going to understand quality as it pertains to architectural millwork, the role and purpose of the NAAWS manual as a tool of specifying and determining the referential standards of quality, the critical elements that are required in submission drawings for compliance, and why the GIS process is so important and allows the bid process to be conducted on a level playing field, standardize the information expectations, and allows all of us to realize consistently better project millwork outcomes. The reality of it is that GIS jobs do actually tend to run smoother and have better outcomes. It's not an exclusive point where it's always the case. There's plenty of non-GIS jobs that go well, but it's important to understand that GIS jobs actually do go well, do tend to run, have a better outcome when the job is finished, and tend to be the projects that everyone is really proud of when they're done. So AWMAC, as you know, our vision is to be the architectural woodworking authority in Canada, and our mission is to develop and promote the use of the quality standards for the manufacturing and installation of architectural woodwork. We provide education on millwork and woodwork throughout the industry. We assist all the stakeholders in projects, and we provide a level playing field throughout all the processes to make sure that everything is clear and quality millwork outcomes are always realized. And there's always protection and assurance of quality materials and quality labor. Now, for a little backstory, back in February 2018, the National GIS Committee assembled the entire National Committee of all representatives, administrators, and inspectors in Victoria, BC for an open and honest roundtable review of the GIS program. This brought well over 400 years of combined woodworking experience into one room. The program and procedures were reviewed, critiqued, and a number of takeaways were generated on how to standardize our program across Canada and how to overall improve the quality of millwork and the quality of service that AWMAC was providing. Our key takeaways kept alluding to the need for higher standard of submissions and submission review. Almost every deficiency that was found on site could have been caught at the shop drying stage. The level of submission quality has been declining over recent years, and the adherence to AWS and the NAAWS requirements was dismal. Our inspectors now regularly meet via Zoom to collaborate to standardize this inspection process. AWMAC as an association needs to actively educate our members to elevate our quality, in addition to just acting as a watchdog. So this is why we have these CEUs. This one is on shop drawings. There'll be some further later this year on lumber grading and veneer grading, so that everybody's understanding more. Without education, being simply a compliance body isn't enough. Our inspectors collaboratively created a top 25 hit list of the most common errors and omissions, 22 of which would have been picked up on a shop drawing review. For those of you who don't know, Lori will send this out with the GIS startup package on every single project. So the NAAWS is AWMAC's collaboration with the Woodworking Institute out of California and resulted in our 2017 release of the NAAWS version 3.1 and the subsequent release of 4.0 in July of 2021. NAAWS manual is the comprehensive set of standards, represents the best practices of what these two organizations have to offer in defining the requirement for material and workmanship for the fabrication and installation of architectural woodwork. It is in use by design professionals, building owners, contractors, millwork fabricators, installers, suppliers, and educational institutions across North America. The purpose of the NAAWS is to provide the woodworking industry with the logical and simple means to comprehensively specify and determine what elements of architectural woodwork are in compliance in their climate-controlled environments and will meet the functional and aesthetic requirements of the clients. That's really a mouthful. But really, it provides compliance criteria to ensure that all manufacturers and installers are bidding on a project and they're competing on an equal basis. And it provides everyone with the same level of standards and outlines what is the minimum standard that's required for architectural woodwork. The heart of the manual is broken into 15 sections that each focus on and outline the minimum acceptable standards for the differing elements of architectural woodwork. From submittals through sheet goods to millwork and trim to countertops, NAAWS provides clearly identifiable standards for millwork acceptance. They are not open to interpretation. They are all clearly objective and can be measured. We're really trying to make the process as objective as possible and remove all the gray areas of whether or not something is compliant. And that works both ways. It allows the manufacturer to be able to stand on his platform and state that yes, his work is compliant and can't get bullied around by the architect or the general contractor, every bit as much as it provides the owners the ability to say, hey, I did or did not get what I was entitled to. The compliance sections throughout the NAAWS have green headers, and they indicate the relevant section and are broken into subsections regarding material rules or assembly rules. Installation and test rules now have been moved over and have their own sections. Throughout the manual, you see reference to quality grades. There's different quality grades, premium and custom. Economy grade was dropped in 4.0 as it has no place in the quality millwork that we are doing. Premium and custom grade have the same structural integrity and stability. The only difference is tighter tolerances and upgraded aesthetic requirements. And grades can be mixed on a project to get the best value. So premium grade in the showcase areas and custom grade for the balance of the work. Custom grade provides the best all-around balance of quality and cost, and it's appropriate for almost all millwork applications. So you take a few minutes to look at the in-depth information on the grades as it applies to, for example, grain on cabinet surfaces and fronts. As you'll see in the manual, it's all broken down into two grades, custom and premium, and the grade will be specified on what's required. As you go from left to right, what tightens up as you move through the grades is tolerances, fit and finish, and certain aesthetic elements. On these cabinet fronts is the reason why it looks more organized in the premium grade. First of all, here, there's two cabinet elevations. 2 cabinets in each elevation, a 4-drawer unit and another unit with 2 drawers and 2 drawers. And that's consistent. In custom grade, you'll see that all 3 of the vertical stacks are matched. So the drawer front at the top matches the 4-drawer fronts, all in alignment. And they've been cut out of the same piece of veneer and they're in perfect alignment. There's some differences between the 2 cabinet doors. There's no requirement custom grade and they're sequentially matched between the cabinet and unit. They have to be compatible for grain and color. So they have to be similar and they have to look good together. But they don't have to all come out of the same panel. But when we get to premium grade, all 4 of these panels within this single cabinet have to come from the same piece. The 4 drawer fronts have to be from the same piece. One of the most things that's misunderstood about premium grade, when you have a big elevation, the doors and drawer fronts don't have to be sequenced from one cabinet to another. They have to be within each cabinet unit. And then they do have to be well matched for color and grain across the entire elevation. Now, it's not to say that the designer can't require sequential matching, but they have to spec it. Each compliance rule applies to custom grade. Any additional premium grade throughout the manual is highlighted in yellow and adds the suffix P on its code number. Section 1 covers submittals. Submittals consists of both shop drawings and samples. NAAWS outlines the standards expected for shop drawings and sample submissions. In the computer word, the vernacular they use is GIGO. Garbage in, garbage out. You can't expect good results from a flawed or a mediocre startup. Another term that we're working to eliminate is PEBCAC. That's an IT term that basically means problem exists between keyboard and chair. So we're going to remove the human error and the human element that doesn't understand and doesn't know what's required for proper millwork startups. Now, something to point out also is that the NAAWS standards for these submittals are not new. They were virtually unchanged when we created NAAWS 3.1 from AWS 2.0. And then they were all just really a reformat of how it was presented in AWS 1.1. So we're really looking at about 15 years at least of requirements that haven't changed. It's just how it's been packaged and how it's been laid out. Everything that you're reading in these, if you go back to the old manuals, you'll see they actually were the same requirements back then. When it comes to submittals, there are no grades. All projects are expected to have this information, so the GC owner and design professionals get an accurate picture of what's being provided and how. Whether it's a GRS job or not, this is the minimum standard expectation. The standards are pretty clear and stringent on the requirement for accurate and effective shop drawings. Copying and pasting architecturals and figuring it out on the fly is a no-go, and it's not going to work out well for anyone. So in this case, I went through and I pinched some drawings from our very good partners in the Woodwork Institute on a presentation that they do on quality. And I also have a good friend of mine who's an AWMAC member in another province, whose drawings are typically pretty clear, concise, compliant, and all around really good, although I won't admit that to his face. So if he happens to be around and seeing this presentation, that's as close as a pat on the back as you're getting from me. So. Starting off, we do cover sheets. We need specific project information required. This is why we say you can't copy and paste. We want project location, mill worker, contact information, designer information, general contract information. We're looking for all these details presented throughout the job. All this information, really, baseline. Now, before I go on, I want to point out something. AWMAC, our inspectors, no one is asking anyone to change their drawing package. Everybody's drawing software that they're using is proprietary to what they're working with. It has to work with your CNC, it has to work with your production, it has to work with your any kind of ERP that you have in place. No one is telling you to change what you use to draw. What is essential is that the information that you provide, either supplementary or through your drawing software, provides us with all this data. This allows the inspector to check that you are being compliant with what you're doing. It allows the designer to see that you're compliant and you're meeting their design intent, and it eliminates the chance that there's any discrepancies down the line where someone says, I was never told this wasn't brought to my attention, and this isn't there. And that's why it's essential this information is presented on every project. So we typically want to start off the drawing legend. What's in the drawings, what's been detailed, and where can I find it? A listing element, a listing of all of our elements, all of our finishes, all of our materials, all of our hardware. Remove any chances that something that wasn't indicated somewhere isn't going to show up here. This is going to work to the millworker's advantage as well as the client's. Any changes, alternates, or alterations can be determined before any piece of wood hits the saw. What's your finish? What's the casework fabrication details? What kind of hardware are we using? What is included that is part of the AWMAC specifications and sections? A lot of people like to work with typical details. There's nothing wrong with that. Using standardized details that correspond to the manufacturer's established methods keeps you from having to redraw it every time. As long as these details don't contradict the designer's drawings and don't contradict your details anywhere else, there's nothing wrong with using standardized details, and starting off with a legend helps understand where these details are and where they're going to be occurring in the drawings to come. In this case, we've got J, K, and L, which are going to detail the upper cabinet details at the front and top edges.
Do we have anybody going to kitchen?
So here, whenever we reference J, K, and L, and we correspond to the top detail for a scribed filler, simple top, or a full soffit panel, we can reuse these on other drawing package, and we don't have to keep reinventing the wheel.
I'm going January 26th.
Similarly, we're going to go after joinery, especially drawer box or other repetitive joinery elements. Once it's been detailed, it doesn't have to be repeated as long as you don't contradict it later. So this is where you got to spend time and make sure your details are thorough and clear, and they work with your materials on this project. Or you just might find yourself trying to dovetail melamine. So you can let me know how that works out later for you.
It's riverside laminated.
Starting out as well, our next thing we're looking for is we want to see a key plan. We want to find all the millwork elements. What building is it in? What floor? Which way's up? What room am I going to? And what drawings will I find these elements?
It's my birthday and my anniversary with my girlfriend. I have no 2 days off. January 27th, I'm gonna turn 30.
So in this particular elevation, we're looking at elevation 2 and D9. The elevation drawings need to show the crucial elements where everything's got to start from. Blocking in the walls. Casework sizes. Material finishes for this elevation. And any specific notes for this location. The splash, the cutouts to be sealed, etc., etc. We're doing doors and hardware or some repetitive elements, even base, tops, we can use a schedule. Any specific or non-standard dimensions or specs are going to be required. And we pull up common elements and grid and schedule all these elements. Blow-ups and details of any relevant dimensions are by type or by location. Further drawings can expand and show the sections, details of scheduled pieces. Wall and ceiling panel is where the visual concept and coordination elements really have to be spelled out. So from your materials, your colors, matching, your sequencing, and your sizing with walls and other elements performed by other trades. Cross sections have to show your finished dimensions and construction details. They're a must. to ensure that finished paneling actually is going to work in the finished space. You're trying to convey in your shop drawings both the design intent as well as the constructability of these elements. Prep for hardware. Precise locations and dimensions are the key to coordinating quality work, whether the hard work is by the millworker or by others. You can't build it if you didn't draw it. Geico. And then custom millwork is going to require a custom solution, which means it's going to require custom drawings. As the millwork experts, we have to find the solutions to create the visuals to what we're provided. Turning the ideas into reality are going to require details, and they can't just be copied, and we can't expect the designer to know how to make all the details that they've asked for. And that makes sure everything is planned out before it's cut. Because what seems like second nature in the shop is not going to be the case on site. The best millwork is fully built before the material even arrives in the shop. If you didn't draw it and you didn't show it, how can anybody expect that you can or will make it?
These guys have the worst shop drawings ever. Like, to the point where, like,
in the event of a conflict between the specs and the NAAWS, we defer to the design professionals' specific requirements. The narrative we give designers is that we caution them that if you override the NAAWS standards with an incorrect or in substandard practice, we're going to have very little recourse on what happens if it's non-compliant or deficient. As an AWMAC member, you're supposed to highlight these discrepancies, and an inspector will do the same thing to your GIS review. But the authority remains the contract documents. So you have to be familiar with the specs and the standards as you're working through them. It's not in anyone's interest to have the millwork fail, so it's more importantly that you communicate this and don't wind up in a contract dispute.
See? That's why.
NAAWS has been incorporating a lot of the master spec templates through the Spec Writers Conference and the Spec Writers Council. So that should help keep things termed properly. We spend a lot of time working behind the scenes to make sure that they do help designers and architects spec the work properly so that we're not actually digging through a lot of crap at the end. And that's where the GIS comes into play.
I don't want
It's a national program that's evolved over 24 years now of architectural woodwork and helping to guide everyone through expert inspections and qualified industry specialists, and helps bring projects to a successful end. AWMAC and the inspectors actively want to see the millworkers succeed. The inspectors are looking to work with you to help bring up your work to the standards and beyond. Once specified, the GIS is a 3-step process with a written report issued for each step. There's a shop drawing review in addition to the usual review by the architect. There's a sample unit inspection in the either on site or at the shop, and then a final inspection on the completion that is inspected for compliance and provides a report for anything that needs to be rectified or anything that isn't meeting the standards. This is a sample GIS report. The inspector will indicate what was inspected, to what standards, and to what was compliant and what wasn't, with the correct reference to the standard that actually applies.
Doing whatever they're doing, like planning out in like SolidWorks or like Inventor, like the one that sounds, and then especially even the simple.
When shop drawings are being reviewed, a whole list of the missing information will be provided, whether including what answers aren't clear in order to determine if the items were compliant, and a list of what items don't meet the specs or what specs don't meet the NAAWS standards. Do yourself a favor, don't let the GIS inspection be your only check and balance as to whether or not you provided everything. Do an internal check. Make sure that you guys are providing as close to compliant drawings as you can humanly do, and let the inspector double check to make sure that you did. You'll also see on your reports what NAAWS standard is referenced, and they're verbatim out of the manual, so you can see exactly what you were required to do.
I have a little bit of experience with SolidWorks.
Okay, so you're going for this weekend and picking up the sample.
I bring it on Monday.
The inspector works from a comprehensive checklist. All of these items are extracted from the NAAWS Section 1 and the other relevant sections.
To get that.
Nick, can I just make one quick point?
Sure.
Do you think I should claim
Chapter
that
1
sample?
is
Because
it's
it
not,
needs
it's
to go down to
submittals.
the
It is a very
Caribbean.
small chapter. For anybody who does shop drawings,
Caribbean?
I suggest
The
you
sample.
read that chapter.
Okay.
That'll save you
Caribbean?
probably
No,
lots of
the-
issues on any of your shop
No,
drawings.
GML is going to
100%.
take it and go on a flight.
And then when it's a GIS
down
project
to-
again,
Because
there'll be a
believe me, I would
certificate
take
of
that
guarantee
flight.
issued. AWMAC stands
I would-
behind the work of our members.
What is it
If you
for?
follow the standards, we'll issue
Some
a
sort of
2-year warranty
project.
for that project. We guarantee that the workmanship and the materials that you followed will not fail.
We did for
Now the service, remember, is the inspections and the reviews. The guarantee is a bonus to our members. Non-members are expected to provide a 2-year warranty bond to the owners,
Same as
provided that they actually
Peter
met
Gallagher
the standards and met the rules,
from
and their
Comfort
stuff will hold up.
Mm-hmm.
Most of their projects are down in Bermuda and BVI.
To enjoy better project outcomes and rest a little
They do a
easier
lot
at
of
night,
hotels there.
knowing that you minimize that things are unclear. Work to the AWMAC Standards Current Edition, that's NAAWS 4.0. Support the GIS program. Work to a scope of work and a comprehensive materials list where you are clear. Provide clear and concise shop drawings that show what will be built and installed and how. Holy crap, I'm almost done. That gives us a lot of time for questions and feedback.
We'll open the floor if you'd like to ask a question.
Was it done?
Please just unmute yourself and go ahead.
Yep, it's done.
Is the PowerPoint able to get the PowerPoint presentation? It was pretty good.
Oh, I'm recording.
Oh,
Well, there's no
I'll
way
send it
that
to
was
you.
enough for everybody, so
thank you.
there has to be some questions from the floor.
Okay, if we don't have any questions, if anything does come up, please feel free to send in your questions. We can have them answered for you. Nick, I know he's, as I mentioned, he's a huge resource, so please don't ever hesitate to reach out. You can reach Nick directly at president.on@awmac.com, or you can send it through the office and I'll make sure to send it to him.
Hey Nick.
Yes,
Yes, I have a question.
please.
I did a couple of months back a drawing and I got a report, and I just want to know one question. How do you show countertop joint locations and fasteners? How do I show them in the drawings?
Well, your fasteners that you're going to wind up using is probably going to be a common detail that you're going to use. You're going to use dog bones. You're using a tight joint, whatever you're going to wind up using underneath. As far as your joints, you're probably in plan. You'd be doing drawings that indicate where your joint location is. That's going to help us locate and make sure that you're not on a sink location or that you're not falling on a cabinet, like an open span under a cabinet. That's the best point. So typically dotted line or even a straight line indicating it's a field joint. Now,
Okay.
the difference is going to come down to whether or not it's a field joint, in particular when we call it a discretionary field joint, which is
Yeah.
where the installer is going to have to put it together on site, or a joint that you have fabricated in the shop. Joints in the shop are a different story. That top is not considered. That's really not considered to be a field joint. We're more worried about field joints on site.
So in the drawings, I can just show as a dotted line and explain that, saying that this is the typical joint for a countertop, or with fasteners showing some small dots.
Yep.
Or a dot bone, right?
A dotted line, or a lot of times we used to just do a straight line and we'd put the notes FJ on it, and then
Okay.
someplace we'd have a legend indicating that FJ is field joint,
Okay, feet joint.
and that's helping both my installer to figure out to see where his joints are and what his order of operations is going to be in order to install it from the right way, as
Yeah.
well as the designer to see where they're going to occur.
All right. I have one more question.
Please.
In one of the drawings, I have shown what do you call blocking dimensions, meaning when we install the upper and the lowers, I have to show where the blocking is.
Yes.
So I can show as a single line, or I have to actually create a box and say this is the location.
Typically, we do a drawing, a dotted line on the elevation and or the side section showing where the center line of that blocking is going to be.
Oh, okay. All right.
So
okay.
if we go...
Makes sense.
Oh, this is going to be... I suppose I can do this. Let me go back to that detail and show you what the best practice for that typically comes up as.
Okay.
Here. So here you're looking at your elevations, and you'll notice here we have dotted line.
Yeah.
With the height above finished floor, showing
Yes.
you the center lines to your blocking.
Oh, okay. All right. And
it's important you have to spell that out. A lot of times what we'll wind up doing, another option that you can do is what I've done a lot of times is I've taken the elevations off this is one of the times we take, it's almost like when you're going to copy and paste from the architect's drawings, but you're doing a set of drawings early, like you're doing it before your main submittals, you're doing only blocking drawings because the drywaller is fast and furious. He's throwing up 18 gauge sheet really quick, and they want to know where the stuff is, and we're late to tender, so they want to know the center lines of the blocking early. So you can take the elevations of millwork that are going to be on the job and give them the center lines of the blocking that you're expecting. If he's putting up the proper levels of 18 gauge sheet strip, roll sheet, that's going to give you some flexibility in order to make sure that, within an inch up and down or a couple mil here and there, you're going to catch blocking. So we can do that in a separate drawing as well. But then when we're doing our elevations, we show our sections here where we want the center lines of our blocking to be, and then whether they choose to put in plywood, 18 gauge roll stock, solid blocking, either way, they know where it has to be. We have to dictate to them where it's going to be, because otherwise they'll do nothing.
Okay. All right. I got it. That helps. Thank you.
Anybody else? Must have spoken very quickly.
Yeah,
I went
Nick?
that spreadsheet, that slide very quickly.
Nick, someone's calling.
Yes, sir.
Nick, it's Brian from Ladson. Just a quick question on imperial as opposed to metric dimensioning. So this example that we have sitting in front of us, that's imperial. But if the job specifications, if the job contract drawings come out in metric, then the shop drawings have to be in metric. Is that correct?
That is, what did I say about the NAAWS versus the specs? What governs?
Okay, so, fair enough.
The NAAWS has both standards, so everything you see, you've got metric and imperial through the entire manual. So you have a reference in both standards. Now, some people will draw on both. Some people will draw on one or the other. Typically in Canada, we still see imperial, but it's getting more and more and more metric. If you deal with a lot of companies in the U.S., they don't want to see metric at all. A lot of times, they're getting a little less fussy about seeing both. But there was a time when if there was any metric on the drawings, they would send it back. So you're going to have to figure out what the architect that you're dealing with on that particular project wants to see. And then you're going to have to work with any discrepancy that you have between working with imperial nominal dimensions and metric nominal dimensions. When I was at Galanders, we did a lot of work in the States, and it was all in imperial, and they didn't want to see metric, but our shop was completely running in metric, 100%.
So if you had a combination of the two, I think you're going to say no, between, let's say, dimensional aspects and then fasteners that you've written, dimensional aspects like casework being in metric and then having fasteners called off as imperial fasteners, then could that or would that be rejected?
No.
Okay, just asking.
No, that would never happen because a quarter 20 screw is a quarter 20 screw.
No, I get it.
It's not the same as an M6 screw. They're completely different animals. So there's no reason that a number 8 by 3 inch screw is what we're going to mandate every time. No one's going to call it a number 8 by or a number 10 by 76 mil. It's So no, that the mixing of the two isn't the issue, and it certainly isn't an issue within NAAWS or within our standards. That's more of the palatability to your end user.
Yeah. Okay. Thank you.
But there's likewise. I mean, I push back even on our own inspectors sometimes. And even with the NAAWS committee, we've indicated in Section 1, minimum standards for drawing scales. That's not as cast in stone in the days of electronic drawings as it really needs to be. So we're really that's a guideline to a blow up needs to be a blow up. But whether it's 1 to 50 or it's 1 to 48.5 when the metric drawing is actually scaled up, that's not really something that's going to cause for a drawing to be rejected. It just might be a notation that your inspector says, hey, you know what, your blow up wasn't quite big enough, or when it's really off, you didn't get even close to your blow up. Nowadays, drawings aren't getting printed, certainly not in 24 by 36 or 36 by 48 like they used to be. So making sure that your stuff is legible is really the most important part of that. There has to be some balance between reality and we live in the real world.
Hey, Laurie, just one question. Can we get this recording or a PDF copy of this presentation?
Both will be made available once this presentation is complete. If anybody would like that, please just send me a quick email and I'll get the link for the video and I can email you the PDF.
Okay, I will send that email to you. All right, thank you.
Okay. Thanks.
Yes, one of the things we're working on is anytime we're doing any of these CEU seminars, we're trying to create a better repository so that your new employees can go back and find them and access this information. It's not a secret. There's a reason that the NAAWS is free. The NAAWS is free to everyone. If anybody's ever had to buy an ANSI standard or an ISO standard or anything like that, they're a lot of money. As part of the NAAWS committee, I've spent a lot of money having to buy the NHLA documents or the WDMA documents. We incorporate all that into the manual and we make it free, because without these standards being in everybody's hands, we can't hold people accountable. It's in our best interests as an industry that these standards are in as many people's hands as possible. So there's no secrets in what we're doing here. This is calling for quality millwork. There's no tricks. There's no hidden agendas. We're trying to level up everybody's quality, and that serves to the best of the industry as a whole. So if you have questions, they need to get answered.
Any further questions? One quick note, if anybody, as a manufacturing member with AWMAC, we invite you to join us when we do presentations to architects. If anybody is ever interested in seeing what we say to architects, which is a lot of what you see here, again, please let me know and I can give you some dates of when we're visiting, and you can be my technical advisor. It's always great to have you join us.
Okay, well, if there's no other questions, Laura, I'll turn it back over to you.
Okay.
I want to thank everyone again for attending, and I really do mean it. If you have any questions, reach out. We can get them answered by myself, by an inspector, or by anyone.
Thanks, guys.
Thank you. Thank you, Nick, and thank you, everybody, for joining us today. Have a wonderful afternoon.
Thank you.